everyone. Good afternoon. Hope everyone is feeling good today. Hope everyone has been paying cheaper transaction fees today. So a big change happened to Ethereum about 3 weeks ago, right? And this change is the Denkun hard fork. And the biggest feature of the Denkun hard fork is something that we called proto-dank sharding, or something that we call blobs. Blobs are basically a separate region of space within an Ethereum block that is intended as separate space for containing data which rollups can use to put the data for their transactions, right? So create more space inside of Ethereum blocks, specifically for the goal of increasing the scale of Ethereum-based Layer 2 projects. And as we see, there is already quite a lot of rollups and a lot of Layer 2 projects that are actually starting to use Ethereum blobs already. As a result, Ethereum has become much cheaper. So if you go to, I think l2fees.info, or .io, I forget which one, you'll be able to find that rollups today cost less than 1 cent to send a transaction, right? So less than 1 cent, right? This is a very big decrease compared to 2020. It's even a big decrease compared to 2017. So scalability is well on the way to actually becoming a solved problem. Now, EIP 4844, so the EIP that brought us these blobs, it's designed not just as a one-time thing, but it's designed to lay the groundwork for future scaling of Ethereum using this technology called data availability sampling. So with data availability sampling, the idea is that instead of each node needing to download every single part of a blob, each node only needs to download a small portion of the contents of a blob, and it uses this random sampling approach to verify that the blob has been published and that the data is available. So if blobs today, the blob limit target is about 3 blobs per slot, so that's about 375 kilobytes of blob data per slot is the current long-term limit in Ethereum. But with PeerDAS, which is the next big upgrade to this system, the plan is to increase that to around 8 to 16 blobs, which basically means around 1 to 2 megabytes of roll-up friendly data in each slot. And after that, the plan is to go to full dank sharding, which gets you to 16 megabytes of data in each slot, right? So 16 megabytes per 12 seconds, 1.3 megabytes per second, divided by 20 bytes a transaction with optimal compression, and that's 70,000 transactions per second on Layer 2s on-chain, right? This is the goal. If you want to go higher than 70,000, there are also other technologies that you can use, such as Validiums, Plasma, optimistic data availability, and so on. So these upgrades that are going to be done in the future, those are upgrades that actually require only a very small change to the Ethereum protocol. And they actually require no change on the part of rollups themselves to support. So if you are a Layer 2 and you have already switched to be based on blobs, then you do not need to make any further changes in order to be compatible with Ethereum's blob scaling roadmap going forward into the future, right? So blobs were a large change today that is meant to enable very smooth scaling tomorrow and going forward many years into the future. So from the Ethereum protocol point of view, the only hard fork required is a change to the parameters. Everything else actually gets done in the background by changing parts of the software of Ethereum consensus nodes over time. So this is where data availability sampling is going. Now, the Ethereum ecosystem is also upgrading using other technologies. So ZK snarks. ZK snarks have become a cornerstone of modern Ethereum applications. And ZK snarks have 2 use cases. One of them is privacy, and the other is scalability, right? ZK snarks are zero knowledge, succinct arguments of knowledge, right? So zero knowledge means it protects your privacy, and succinct means that the proof is very fast to verify, even if the proof is representing a computation that is very large. If you have a computation that is very large, you only need one person to generate a proof one time, and once they generated a proof, that proof becomes extremely fast and easy for anyone else to check, going forward an unlimited amount of time into the future. So ZK snarks are a powerful scalability technology, they're a powerful privacy technology, and by doing this, they resolve both of the major problems both of the major things that are weaknesses of blockchains compared to more traditional centralized technologies. So ZK snarks are one piece. Account abstraction is another piece. Account abstraction basically says, instead of just having accounts that are controlled by one single private key, where if you lose that private key, your account is gone. If someone else gets that private key, they can steal all of your assets. You have no way to change the private key. You have no way to change the algorithm. We create a system where users can specify the code that protects their account, and they can put any kind of custom logic. You can put multiple keys. You can put other algorithms. You can put post-quantum algorithms. You can put mechanisms for changing the key. You can put different algorithms that let you do your signing inside of trusted hardware modules. Account abstraction unlocks a lot of things for security, and this is another one of those areas where the Ethereum ecosystem is in the process of upgrading quickly. In one of my recent posts, I had this chart of the differences between how to build on Ethereum today and how to build on Ethereum 10 years ago. Building on Ethereum 10 years ago was simple. Architecture, you build on L1. Privacy, you have no privacy, everything is public. Anti-Sybil, how to protect against millions of people making spam accounts. You require people to have 0.01 ETH. Wallets, externally owned accounts, just single private keys. Proof of community membership, if you have ETH, you're part of the community. So these were like the tools that we had back in the 2010s. In the 2020s, we have access to much more powerful tools, and this leads to different ways to create applications. So architecture, build on a layer 2. So you can build on an existing layer 2, you can make your own layer 2, or you can build your application in such a way that it supports every layer 2. Privacy. So you can build applications where data is kept with the user by default, and the only time when data needs to be revealed is if the user needs to prove something about themselves to other users in order to be trusted, right? So instead of just revealing everything to everyone, you choose what to reveal, to whom you're revealing to, and you reveal just the specific pieces of information that you need to be trusted. Anti-Sybil. So applications still can require an ETH deposit, but the challenge with ETH deposits is that non-crypto users do not have ETH, right? And so if you want to support non-crypto users, then as an application, you can create a wrapper, right? And you can just say, if someone proves that they have a phone number, they verify an SMS confirmation code, then the app itself can send the ETH on-chain on their behalf. This is actually something that a lot of decentralized social projects are doing already. So Farcaster is doing this, other applications are doing this as well. Wallets. So account abstraction, you can do key recovery with account abstraction. You can have different levels of access control for different amounts. The amount of security that you should have to go through to pay 5 USDC for a coffee should be much, much lower than the amount of security that you need to send your entire life savings to someone. EOAs do not do this, right? With an EOA, either everything is on your phone and it's easy to send your money, but it's also easy to steal all of your money, or you have 12 words that are inside of a lockbox somewhere in your basement and it's very hard to do anything. With account abstraction, you can have smarter forms of access control, where smaller amounts of money are easier to send, and larger amounts of money are more difficult to send and are also more protected against attacks. Proofs of community membership. So we have ETH, we have the proof of personhood protocol, we have a proof of attendance protocol, we have POPs, we have zoo stamps, which are a zero knowledge version of that, Ethereum attestation service, EAS, third-party curated lists. We have all kinds of different ways to verify to what extent someone is a member of some particular community. Now, this is valuable for a lot of applications, even inside of the Ethereum community itself. So for example, airdrops. If you create a new token, you want to widely distribute that community or that token to people who are in your community, to people who are part of your ecosystem, who are not just going to dump the token and forget about the project. You want to create some distribution that actually reflects how the people who have contributed to making your ecosystem be what it is. In order to do this efficiently and fairly and in a widely distributed way, you need to have more different ways of actually verifying, like at a very large scale, what kinds of users made what level of contributions, to what extent are different users actually a part of your community. We have many more tools than we did before to do that as well. So Ethereum in the 2020s has a lot more of these powerful tools. And if you're building an application on Ethereum in the 2020s, then you need to start from the perspective of using those tools. Building an application on layer 1 where everything just gets dumped on chain, even if it doesn't need to be, is no longer acceptable, right? Applications need to be efficient, applications need to be easy to use, and applications need to be secure. One analogy that I use for Ethereum and what the Ethereum ecosystem is like today is, think of a country that contains cities, right? So people sometimes ask, well, Ethereum is confusing because, well, you have Linea and you have Arbitrum and you have Starknet, and like, what do you do, right? And I say, well, okay, fine. Well, India is confusing, right? You have New Delhi, you have Chennai, you have Bangalore. Where do you live, right? And I think you can think about it in a similar way, right? You can think that basically Ethereum is like this very big thing, and you have a lot of these different nodes that are inside of it. And these different nodes, they're all part of Ethereum, but they also have some of their own features that are very unique to them, right? And you even have sub-ecosystems that are inside of Ethereum, right? So for example, you have the Optimism ecosystem, and Optimism is inside of it. Base is also inside of it as well. You have the Starknet ecosystem that has multiple chains. You have Polygon, you have individual rollups, you have Metis, you have Scroll. Fuel, I think, is very underloved. Fuel is not an EVM rollup, but Fuel is great because they're one of the few that actually is fully protected by code without needing any security councils or backdoors or any of those kind of training wheel features that a lot of the more complicated rollups have. So there's a lot of different things, sub-ecosystems within the Ethereum ecosystem, and I think it's okay to just choose one of them and to build inside of one of them. And what you get is you get a very high level of interoperability with other applications inside of your sub-ecosystem, and you also get a medium level of interoperability with this entire greater Ethereum ecosystem, right? You get both. So this is the way that I think about layer 2-centric Ethereum and what it means to build inside of it. What kind of layer 2 do you build on? This is a very important question for anyone building applications today at a large scale, right? And I think you have two choices. Your first choice is, do you build on a general purpose rollup, which usually means something EVM compatible, or do you make something special purpose that's targeted to your application? And the second choice is rollup versus Validium. So in a rollup, data is on-chain. In a Validium, data is off-chain. In a rollup, you have the strongest level of security. So even if all of the other rollup nodes disappear, you can still get your assets out. Validiums have a slightly lower level of security. In a Validium, your assets can get stuck, they can get frozen, but they cannot get stolen. So it's possible for nothing to happen, but it's not possible for something invalid to happen. But the benefit of a Validium is that Validiums can benefit from much lower transaction fees. So what kind of L2 is special purpose versus general purpose, and rollup versus Validium? So how do I think about EVM compatible versus special purpose, right? I think EVM compatible rollups are better for use cases that interact a lot with the rest of the existing Ethereum ecosystem. EVM compatible rollups are better for applications that already are Ethereum users. EVM rollups are great for DeFi. They are great for smart contract applications of the type that people have been building a lot of already. Special purpose is better for very high throughput, and special purpose is better for porting existing centralized applications, right? So for people who are trying to build enterprise applications on blockchains over the last 10 years, you might remember 5 years ago, the thing that everyone was shilling is to build on a consortium chain, right? We remember consortium chains. Consortium chains, I think, mostly have not ended up really working well. And my own explanation as to why is because I think consortium chains were trying to be a compromise between centralization and decentralization and trying to get the benefits of both. But I think the reality ended up being that consortium chains instead combines the disadvantages of both. They did not get the benefits of being part of a truly open global ecosystem, and they also did not get the efficiency and the scale that might come from centralization. And so I think layer 2s are actually, and especially application-specific Validiums, are actually a much better strategy toward achieving the same goal. So let's say today you have a centralized application, a very high throughput centralized application. Maybe financial, maybe supply chain, maybe something else, and you want to make it a little bit more blockchainy. What can you do? You can keep your centralized application running the way it runs. You can keep the same code, except you also add an extra piece of sidecar code. That extra piece of code follows along the code you already have, and it takes your database and it computes updated hashes of your database, and it publishes those hashes on-chain. It also publishes zero-knowledge proofs that prove that the hashes were computed correctly. Once you have these things, then technically you are already a Validium. From the perspective of existing users, nothing has changed. The existing centralized workflow continues to work as it is. But from the perspective of new users that care about new blockchain-enabled workflows, users can go and they can take their Merkle proofs and they can use those, import those proofs into other applications. So rollups versus Validiums, I think there is a spectrum of basically what level of security do you need. If you're doing high-value financial use cases, or something like ENS, or something like very core forms of account management, then these are very security demanding, and it makes more sense for them to be rollups. If you're doing things that are relatively lower value, so for example, lower value financial activity, games, non-financial enterprise apps, you do not need to put all of that data on chain. And so it's okay to use more scale demanding approaches, particularly Validiums. So conclusions, right? Ethereum is much more capable of supporting mainstream large scale applications than it was 5 years ago, right? 5 years ago, all of this was theory. 5 years ago, all of this was ideas. Today, these things are actual reality. There are software packages that you can go use and download and run. Large-scale applications that are being built today should be built on or built as layer 2s and take advantage of the latest technology. This could mean building on an existing EVM layer 2. So build on Optimism, build on Base, build on Scroll. Or it could also mean building your own app chain as a rollup or as a Validium that uses special purpose code that's optimized around your application. Both of those paths, I think, are completely acceptable. the main choices for developers are ease of development versus performance versus interoperability versus security. And when we say interoperability, there's two kinds of interoperability. You can interoperate with the existing Ethereum ecosystem, and you can also interoperate with your existing application, your existing users, and other things within your ecosystem that you already need to interoperate with. And so I think different choices make sense for different users, right? And in the Ethereum ecosystem, I think the big thing that we believe in is we do not believe that one size fits all, right? We believe that different approaches make sense for different applications. And the Ethereum ecosystem, with all of its different layer 2s and all of the different sub-ecosystems inside it, is very capable of supporting all kinds of different strategies that make sense for all kinds of different builders. So I look forward for seeing more people here build and build all kinds of applications using all kinds of different strategies for building on Ethereum. And let's make the next big wave of applications that really bring the openness, permissionlessness, security, and decentralization of blockchains to many millions and tens and hundreds of millions of users, and actually work together to make those things happen. Thank you.